Okay, so in this video, we will obtain the Maclaurin series for the function sine of 3x over x. And we could find this Maclaurin series starting from square one. That is, finding the higher derivatives of our function, then evaluating those higher derivatives at x equals 0, and then looking for a pattern. And we could do just that, but that would be far too much work since we do not have to start from square one. We can build on previously derived Maclaurin series, namely the fact that we have already obtained the Maclaurin series for sine of x. So if you recall, we did show that sine of x, and we obtained this result from scratch by finding the higher derivatives of sine of x, evaluating them at x equals 0, finding a pattern, and writing the final answer concisely using sigma notation. And this is the result that we've obtained. That sine of x is the sum from 0 to infinity of negative 1 to the n over 2n plus 1 factorial x to the 2n plus 1. And the key is that, again, if we apply the ratio test here, that this series converges for all values of x, and so the equality between sine of x and its Maclaurin series is valid for all values of x. Which tells us we can literally, in this equality, replace x by anything we want. Because the equality is valid for any choice of x, whatever we replace x by, the equality will remain valid. So we can replace x by any number of our choice, but also by any other algebraic expression. Well, what we are interested in here is sine of 3x. So we are going to replace x by 3x. There is this matter of the division by x, but that is easily resolved if we rewrite the function as simply 1 over x times sine of 3x. So the 1 over x tags along, and now we obtain sine of 3x by making the substitution in the previous equality, replacing x by sine of 3x. Again, replacing x in the Maclaurin series for sine of x by 3x, so 3x to the 2n plus 1. Well, let's now separate the 3 and the x by distributing the exponent on each term of our product, 3 and x. So we have 3 to the 2n plus 1 times x to the 2n plus 1. And now what do we do with this multiple of 1 over x in front of the infinite series? Well, with respect to n, the index of summation, 1 over x is a constant. And so we can bring 1 over x in and multiply each individual term of the series by 1 over x. Of course, we are going to pair the two x's together. Of course, x is x to the 1, and we can simplify by subtracting the exponents. And we can now write our conclusion. Let's recall that now this infinite power series is equal to sine of 3x over x. You could of course apply the ratio test on this to show that this Maclaurin series also converges for all values of x, but we already knew this since sine of x already was equal to its Maclaurin series for all values of x. Replacing x by 3x, the equality will also obviously be valid for all values of x times 1 over x, and so the equality is again valid for all values of x. And this is how you can obtain the Maclaurin series for sine of 3x over x much more efficiently if instead of going back to square one and finding the higher derivatives of this function, evaluating at 0, looking for a pattern, if you instead build the Maclaurin series for this slightly more complex function from the initial Maclaurin series for the simpler function sine of x. So once we build Maclaurin series for the fundamental functions, we can then much more easily obtain the Maclaurin series for more complex versions of those functions. And that's it.